Hi folks, in this video I will show how the vision system works. The package found in Asset Store, you can play with 5 scenes. Let's load the first of them and see what it does. Okay, we have a lot of green blocks, all of them in green layer and with observable O1 component. This component only rotates the transform around the origin with random speed. There are two larger blocks, one in green layer and other in blue layer. In the center of the scene we have an object with the vision and vision handler scripts. This vision handler is very simple. When an object enters inside, it has its color changed to red, and when it goes out of sight, its color goes back to green. The vision component has some properties to play with. The first of them is the visible layers. In this property, we may define which layers are visible and which layers are not visible. In this case, only the green layer is visible. Remembering, all green blocks are in green layer and the blue block is in blue layer. So the blue block should not be visible and its color should not change to red. The next property is the visible tag. With this property, you may make visible only objects tagged with a specific tag. You may use layer to filter visibility, you may use tag to filter the visibility, and you may use layer and tag together to build a very powerful and flexible visibility filter. The next property I will talk about is the message direction. Message direction is a property created to give flexibility to the designer. With this property, you set the vision to send its signals to ancestor game object, to the same game object, or to its children. So the vision handler may be anywhere in any game object of the hierarchy. Next property is all frames. If checked, the vision will be processed every frame. If you don't have a so fast object in scene, you may uncheck this property and set up an interval in seconds to process the vision. Normally, if the vision is processed 10 times per second, you already have a very good result. With the eye position property, you may adjust the position of the eye in your game object. Let's see. Let's talk about vision blocker layers. Vision blocker layers is the property where you set which layers will block the vision, which layer will not be transparent. In this case, we have the blue layer as opaque. So every time the blue block is between the eye and the green block will be hidden and will keep its natural green color. Next property is the bound box. If this property is unchecked, only the center of the object is used in calculations to know if it is inside or outside of the vision field. If checked, all corners of the bound box are used in calculations. You have a more precise vision, but it has a price: 8 times more calculations. But this is not a problem. You always may add 2 or more vision components to have a better result. Let me give an example. Imagine that you have a lot of small objects that the center is enough to know if they are inside or outside. one vision with boundbox unchecked will resolve. But you have some big objects in the same scene asking for some precise verification. Okay, add another vision with a different visibility filter and with boundbox checked. Problem solved. Simple like that. Now I will talk about the types of the vision fields. We have sphere, diamond, and frustum. Let me check the draw lines to show them. In frustum field of view, you may adjust the near rectangle and the far rectangle. In both cases, you may adjust the size and the center. In diamond field of view, you may adjust the angle defined by this line and the distance of the vision. In sphere field of view, you may adjust the radius and the center. Okay, now that all properties were explained, I will play the scene and change them to show the effects.